In this Godot tutorial, I'll teach you how you can generate and use verification tokens to ensure that the players trying to log into your game server have been properly authenticated. Let's get started. In episode number 3 of this tutorial series, I've shown you this network architecture diagram and explained to you how the authentication server, on a successful authentication, will generate a verification token that it will distribute to the game server and the client. The client will then log into the game server using this token. By doing so, we can create a direct connection between the client and the game server, cutting out any latency that would otherwise be created by having the gateway and the authentication server in between. Now, of course, the game server has to validate that token on that login attempt, and we want to make sure that those tokens are only valid for a set number of seconds, avoiding any exploits. So, in this tutorial, we'll generate this token, we'll do the distribution to the client and the game server, make sure that it's used in the login process from the client to the server, we'll validate it on the game server, and lastly, we have to account for a number of situations that the client may have a faulty verification token, might have a timeout of the connection during that verification process, and we want none of those situations to crash our server. So we have to account for those. Let's get started. Let's dive into generating that verification token. I'm right here on the authentication server where we have our authentication function from the previous tutorials where we check username and password. I've already added a new variable on the top for the token. Right here we got our lines of code to actually generate the verification token, and as you see, I put a couple of prints in between to demonstrate to you how this actually works. What we first do is we randomize the seed of the random number generator, which we use to generate a random number between 1 and 2 to the power of 32. That's a big number. So we're going to get a completely random number, which we first convert to a string. And then we're going to apply the hashing function that is going to return a 64 character long string. It doesn't matter if the random number is 1 or 10 billion, the amount of characters that this function outputs is always going to be 64. So with that hashed random number, we now need a timestamp. And for the timestamp, we're going to be using the operating system get Unix time. The Unix time is the number of seconds that has passed since midnight January 1st, 1970. That's right, that's the number of seconds that have passed over the last 50 years. That is going to be a big number. We're about at 1.6 billion right now, but those two numbers, which comes out as an integer, are going to be super easy to compare. We can compare the current time with when the token was generated, very easily identifying whether those 30 seconds have passed or not. So that will be used by the game server to invalidate tokens once a certain amount of time has passed. So finally, we take the token is going to be smashing these two integers together. So we're going to get a 64 character long hashed variable here. So this is 64 characters, and the timestamp is going to be 10 characters. Now you might be wondering, well, that's 10 characters, but couldn't it get 11 characters? Well, yes, but we took 1.6 billion seconds to pass the last 50 years. So before we're going to get to 11 billion, or above 10 billion, I should say, there's going to be another 200 years at least. So unless you want to really try and make your game stand the test of time and still expect it's going to be played 200 years from now, you don't have to worry. So once we get that, we also define the game server and we're going to be distributing the tokens. Now, to distribute the tokens, we are actually going to be needing a connection between the authentication server and the game server, and we've never really established that connection in previous episodes, so we have to do that first. However, before we do that, let me first demonstrate to you how this works. I got all my servers running already, and I got a client right here, which I'll just turn off, and we'll start up a new client. And we'll log in, and of course our authentication server is now going to be doing its thing. So you see we have a random number that starts with 81. We have our hashed result of hashing that random number. Then we have our timestamp, which ends in 384, and then we smack the two together to get our final verification token. If I were to run this again, I again start a new client, I log in, go to my authentication server. Now you see our random number starts with 585. The hashed function looks completely different. Now we have the amount of seconds, and from 384 we went to 407, and we smashed them together. So like that, we have generated our random number. Now let's look at that distribution. Whoa, future Stefan here. This is of course all dragged out and print commands and everything for demonstration purposes, so you understand how this works. You can of course very easily replace this with just one line of code where you smash all of that converting and hashing and randomizing into a single line of code to make it everything just a little bit more elegant. Okay, back to you, Stefan. Right, now for the distribution of these tokens. As you can see, I'm already calling the game server's singleton right here, and that's a singleton you have not seen before in this tutorial episodes. What I've done, I've created a new singleton, which is now an auto-loaded script, of course. And under port 1912, I've created a new custom multiplayer API, so that this authentication server can not only connect to the gateways, but can also connect to the various game servers that we'll have in our game. So this function is going to be exactly the same as the function we have on the gateway for the peers, the clients. So I've explained everything of how this works, how you can create a custom multiplayer API in episode number 3 of the tutorial series, so I won't go into too much detail. Of course, when we have a look at the game server, here we now have the singleton, the hub connection. The authentication server is going to be the hub for all the game servers. So here you see basically exactly the same as you have on the client to connect to the gateway. Again, I'm not going to be taking too much time to go into this kind of details. Back to the authentication server, what we do here is that as soon as a peer connects, so that peer is going to be a game server, we're going to be saving that game server in a game server list, which is a variable on the top here. And we'll simply give it a name, and we'll save the game server ID, so that when the player connects to a game server, once we have selected a game server, we actually need to know which peer ID that was. So we need to keep a list of all the game servers with their respective peer IDs so that we can call them properly. So that is what this little function does right here, and that is where this game server 1 comes from. As soon as we have programmed in multiple game servers with load balancers, then of course these functions, this hard code game server 1 here, has to be replaced. So what we do, we call the singleton game servers, and we're going to call the function distribute login token. It's as easy as that. We take the token, which we generated, and we take the game server, which is now going to be game server number 1. Over to the singleton, that function will be the function right here. We're going to be determining what the game server peer ID is. For that, we go into the game server list with the game server name that was provided by the authentication function. And we're going to, of course, find this dictionary right there, which has that game server ID. Now, with that done, we can call the RPC ID, game server peer ID that we determined there. We call the function receive login token, and we send that token over to the game server. Now, going to the game server and going to our hub connection that we created, we have a very easy remote function that basically is gonna call the game server. So that is going to be the main node. I've got that on ready for our game server get node root game server. That's the main node of this server. We're gonna go to the game server, and we have a variable there called expected tokens, and we're gonna append the token. So these are the tokens that we expect a connection from. So that's why this is called expected tokens. That expected tokens is nothing more than the conventional game server that we've programmed in episode number 1 of this tutorial series, and we got the expected tokens right here. As you can see, I've added 3 tokens just basically to teach you and show you and demonstrate how this works when multiple clients would be trying to connect at the same time. So we'll get into those in a moment, and then we'll delete them afterwards to show you how it would work if it's completely cleaned up. So that's the distribution to the game server. So now the game server has a number of expected tokens. From the authentication server, going to the authenticate script where we have just generated that token, we also have the RPC ID here that calls the gateway to return the authentication results to the player. So in the previous episodes we only had the result and the player ID, but now I've added the token on top of that. That also means that you have to add that token as a variable onto the gateway, then from the gateway to the second singleton on the gateway that communicates to the player, and then of course the player needs to be receiving this as well. So when we go to the player script on the gateway, we now see that on our remote function return logging request, which is a function we already programmed in, I believe, episode number 3. Yeah, it was 3. We now have that token on top of it, but that went through the gateway. So you have to add that variable on the gateway scripts as well. So right here, we're going to be setting that token if that result was successful. So the result is the result of username and password. And then we're going to call the game server singleton, which is still on the client, which has now the token variable on the top here. And we're going to set the token to that variable. And then we're going to call the game server connect to server. That's not new. That was already the case. What is new, though, is that before we were already deleting the login screen from the world. So the login screen would already be gone. But now we want that login screen to stay, because first we need to verify that we actually have a valid token. So now we only want to delete that login screen the moment the token has been verified successfully. So that has been replaced to a function on the game server, where now we're going to be using the verification of the token first. So with that said, I think we now distributed our token, our player has the token, and our game server has the token. Now we got to look at how we're actually going to handle all these tokens on the game server, and let's program that invalidating function first to make sure that the tokens don't stay there forever. So I'm right here on the game server, under the main game server script, where we have our expected tokens. The expected tokens that we need to be checking whether they need or need not be invalidated. So we could build a invalidation function under the process function that runs 60 times per second, but I don't really care whether it's 28 or 32 or 35 seconds that we check it. All I care about is that we check them about every 30 seconds. So it would be a waste to check this 60 times per second, because it's just going to be using server resources, and I prefer the game server to use those resources somewhere else, making sure players don't have lag, for example. So instead, I've added this timer node to the main node here, to the main game server as a child, and I've renamed it token expiration. I've set it up to continuously keep counting, so as soon as this counts down from 10 seconds to 0, it will automatically restart again and again and again, and it automatically starts when the server starts. On the node signals, I've connected this to the on token expiration timeout signal on the script. So when we go now to this function is going to be triggered once every 10 seconds, which is great for our invalidation process. So how do we invalidate things? We have the current time, which is going to be, again, the operating system get Unix time. And we need to compare the current time to the time of the token. So we need the token time. If the expected tokens, this array on the top here, is empty, we prefer that it does not do anything at all, and we simply pass and wait for the next trigger after 10 seconds. Else, if we do have tokens, we need to check them. First, we're going to be going over every single token by range expected token size, that's the total size of the array, -1, -1, -1. What this actually does is, well, basically what it counters, I can better explain. If you go through an array and you determine that a token in the middle needs to be deleted, all the tokens are going to be shifting one index position up to the beginning. That means you are possibly skipping over some of these tokens while you're deleting other ones out. To counter this, the best way to approach this is by going through the array backwards, or reversed as that's called. So by starting at the end, if we delete anything out, we don't risk at shifting any of our tokens in their index number, because everything that will shift, because yeah, still indexes will shift, but all of those are already checked in this 10 seconds and we can just continue going forward. So with that said, we're going to take the token time, and what we do, we take the expected tokens and then the I, so the index, that's going to return the 74 character long token, and we're going to take the right text from the 64th character. So it's going to skip 64 characters, and then it's going to return us character 65 and onward. And of course that's up to 74. And those are the 10 digits of our timestamp, which we need, of course. So that is the token time. That is an integer, and we have to convert that because the expected tokens starts as a string. And then we simply deduct the token time from the current time, and if that is any bigger than 30 seconds, it means that token has been generated more than 30 seconds ago, and we invalidate it. To invalidate, we simply take the array and we remove it from the array, and gone it is. If a player at that point tries to log in with that token, it's no longer recognized by the game server and says, sorry, you're too late. So now our game server has all these expected tokens all validated. Now we need to do something with it. We actually need to verify a player. So I'm here on the client side, on the player side, and this is where we are immediately presented with a challenge, because the actual connection to the network is made on line number 16 here. But as you can see, there's no place for us to put an extra variable. We can't put that token in there. So the client is actually going to become a peer of the network, and then the network has to request that player to properly verify itself. So we actually initiate the verification process from the game server, which feels a little bit counterintuitive. However, in the previous episodes, we already had this part right here. This is basically whenever a peer makes a connection to this server, the peer connected signal is fired, and we fired this signal, and we were starting the start function under the player verification node. That was a node reference right there. So that is basically still in place. We've just changed it a little bit. First, what we had is we had this big yellow box, and we immediately created the player container without any questions asked, basically. Well, this is what we have to delete, and we have replaced that with these two lines. These two lines start with a new variable on the top, which is a dictionary awaiting verification. This is a little bit of a waiting room in air quotes. And this is going to keep track of all the players that are peers of the network, but that have not had their tokens successfully verified yet. The reason why we have this waiting room is because we don't want players, or don't want to keep players too long in that, between two places kind of a situation. Because as long as the player is in there, the login screen will show a big sandwalker or beach ball spinning of death doom thingy, and the player is just gonna look at that and say like, hey, this is not working. Or what could also happen is that the player were trying to exploit, and for some reason it stays in the waiting room, but that player that was trying to exploit and is still connected to your network is taking up one of the concurrently connected peer seats. And of course, if you have a limit to the maximum number of peers connected to your server, you wouldn't want players to take up those seats while just staying in basically between two worlds. So with all of that said, what we do when we start this function, and that's basically when the pair connects, we first append that awaiting verification dictionary with a key. We use the player ID as a key, and we give it a timestamp so that later we can check whether the player has not been in there for too long. Then we call the main interface, and the main interface is simply the get parent, so that will be the main game server node, and we run the fetch token with the player ID. On the game server node, we have that fetch token, which calls the player through RPC ID and asks that player to run the function fetch token. Switching to the client side, we have the fetch token remote function right here, which immediately calls back the server with the return token function, and it will send over that token that we saved in the variable on the top, and that of course came from the return login request where we did the game server token is token. So with that said, let's now go back to the game server. So we're going to run the remote function return token. First thing we do is we identify who was the player that was actually sending us this token, because we can have several players logging in at the same time, of course. And then we're going to call the player verification process node again, and we're going to run the function verify with the player ID and the token. So this is when the actual verification happens. Okay. The way we start is we're going to assume that the token verification is false. That's the safest thing to do. Next, we have a while function, and this requires a little bit of explaining. What we do is we're going to take the current time, and we're going to check that with the time of the token that was provided by the player. So not the token, not the expected token that came from the authentication server. This is a token provided by the player. So we're going to check that timestamp. And instead of checking whether it's bigger than 30 seconds, we check whether it's smaller than 30 seconds. And here is the reason why. The first thing we do is we check if the main interface, so that will be the main server where we have the expected tokens variables, if it has that token. But, there's a big but. There's a very small chance that that token is not yet received by the game server. Of course, the path from the authentication server to the game server is much shorter than from the authentication server to the gateway, to the client, then to the game server, then the request for the token, and then we're again back to the game server. So it is likely, very likely even, that the game server has received that verification token from the authentication server before the player tries to make the login attempt or the verify attempt of that token. However, if the connection between the authentication server and the game server pings, hangs, times out, if the connection or that packet that was sent is corrupted and needs to be resent again and again because some of those packets were missing, there is a chance that that game server has not received that token yet, but the token provided by the player is valid. So because of that, and because the expected tokens on the main interface are valid for 30 seconds, we're gonna give the player 30 seconds time to successfully verify that token. So if we cannot verify it successfully, we're going to yield the code for 2 seconds, and then through this while function is going to run again and again and again. So with 32 seconds, we're going to do 15 attempts to see if we can verify this token. After 15 seconds, we're going to say, sorry, we tried, but we really couldn't. Please try again because probably something went wrong. So what we do if we have a successful verification. First of all, we set that variable token verification, the start as false, we set it to true. This is the moment we create that player container that we talked about in episode number 4, I believe, the player container. Then we are going to be erasing the player ID from the awaiting verification dictionary. So we're basically going to kick the player out of the waiting room, and that's of course true because it's successfully verified now. And we're going to be erasing the token from the expected tokens on the main interface, on the main game server, out of this array right there. And we do that because of course we only want one connection to be able to be made with one token. So there's no reason to keep that token in the open there. Who knows, maybe the player is working with 2 phones at the same time and clicking login at the same time with the same token of somehow or some way. The last thing we'd want is to have 2 players connect with the same token. That would be weird. That would be exploit sensitive, so we're just going to erase the token ASAP the moment it is used. Okay, with all of that set, we now have an outcome, whether it's immediate after a little bit of a time, or we have the outcome after 30 seconds that we couldn't verify. Nonetheless, of what the outcome is, we're going to call the main interface node. We're going to return token verification results, and we're going to take the player ID and the token verification. So what this does, before we get into those last 3 lines there, we're going to go back to the game server. This function return token verification results is played. We are going to RPC ID call the player. We're going to call that function and we're going to give it the results. That's true or false. Back to the player script, we have this remote function right here. If true, then this is the moment we're going to query the login screen. So that is where we have replaced it to, as I mentioned earlier in this tutorial. We have a successful token verification. Otherwise it's failed, and then we want to enable that login button again so that the player can make a second attempt. Okay, so that is a successful login, but what if it goes wrong? So back to the player verification process, back to the verify function. If the token verification is false, and that could be for 2 reasons, simply because, well, the internet had a hiccup and the game server never received the token from the authentication server, but it could also be when players try to type in their own key, if they were to recompile your game, the executable, and when we do the fetch token here, which is called by the game server, instead of the token, they were just gonna, you know, type a code here and say, well, let's see if a different token will work. Well, when they do that, then this function is going to immediately sort of say, well, that is not true anymore. So we immediately go in here, and this is the moment that, well, this is to make sure that people are disconnected immediately after providing a dodgy key. That's sort of what happens. However, there's another situation, and we'll get to that in a moment. That's another exploit, and that's where this last function here is for. If this happens, so that could be dodgy, could be not dodgy, can be both ways, then basically we're going to be erasing the player from the awaiting verification. So we're going to kick it out of this dictionary, and we're going to be disconnecting the pair from the network. So basically we just kick that player out. The player has received the results, so the client is aware that the result was false and the login has been unlocked again, so the player can make a second attempt if he wants to. All right, with that done, there's one last thing to do. Because if the player, and this is another exploit possibility, if he would provide a token and he understands how the token works, maybe he has sniffed that out with some packet sniff or some sort, and he knows, look, the token is expecting this 74 character string and the last 10 are the Unix timestamp. Okay, let's say the player knows that and he puts a timestamp a year from now instead of the current time. So what that would do is it would make this wow smaller than 30. Yeah, absolutely, because now suddenly that token is going to have a way bigger value than the current time. So the outcome of this subtraction is going to be negative 1,000,000, for example, and that is of course smaller than 30. That means that that player would stay forever in this verification function through this yield function right here, and it could stay there for a year, taking up a seat in your game. And like I said, you have your maximum concurrent users, and you don't want that player to take a seat for too long. So that is where we're going to take that timestamp that we put in the awaiting verification dictionary, and we're going to make sure that that player is still being kicked out. And that's what happens under this function right here. This function right here is initiated by a new timer, again a new timer, under the player verification script. So this is a timer node. I've set this up exactly the same, 10 seconds, auto start on, node connected a signal, so this function is going to run every 10 seconds. We again are going to take the current time and we're going to take the start time. The start time in this case is the start time for when this peer connected. So we're going to do exactly the same if awaiting verification is empty, and I mean the same, it's almost the same function as the token expiration function right here. It's just a little bit different. So if it's empty, we do nothing. If it's not empty, then for every key in awaiting verification, and remember, these keys are the keys we use here, and those are actually peer IDs, player IDs. So that's very important to note there. For every key, we're going to check what the start time was. We simply just retrieved it out of the dictionary because we put it in there with that timestamp. Then we're going to deduct the start time from the current time. And if that is anything more than 10 seconds, then we're going to erase the key out. You can also make this 30 seconds. I think that's where I was. I think I changed it for testing purposes. So if there is more than 30 seconds, then that way the player has been in the waiting room for 30 seconds. We're going to be deleting that player from the array. Now, there's another thing happening here, because now we of course also want to disconnect the peer, and we want to return the verification results, because we do want to tell the player like, hey, your login attempt failed. However, it could be the case under some circumstances that the player was disconnected from the entire client, maybe he lost his Wi-Fi, or maybe he lost his signal altogether. And in that case, it could be that this function runs in a moment that that player is no longer connected. And if you're going to try and disconnect a peer with a peer ID that is no longer connected to the network, you of course going to get an error. So the first thing we have to do after we have kicked him out of the waiting room, we first have to retrieve all the peers that are currently connected to the network. And then if we have that key, so if that peer still exists on the network, then we are going to return the token verification, and we're going to use the key as the player ID, and we're going to return the result false. So that is the same function we run here, and it is the same sort of false but then imitated as there. And we're of course going to disconnect that player from the network, just like we would disconnect it here. Now, with all of that done, we have two print commands right there, so we can check what's going on. But right now we have the entire code that we need to properly generate that token, distribute that token, verify that token, and counter a number of exploits or situations that could happen on the internet. So all we have to do now, I guess, is test it. So to test this, I've maybe not put enough print commands into the various code elements, so we can't really look at the whole process all together as we did in episode number 3. But nonetheless, let's look at if we can actually get a successful connection going. First, we're going to go to the game server, and I'll explain these tokens that I've added here. They're dummy tokens, just for testing purposes. I've added a 7 instead of a 6 here, or I've replaced the 6 with a 7, so there's like 2-3 years in the future. And this third token here, that's an old token, and you can already see the server is running. You can already see it immediately deleted the first token, or the third token I should say. It deleted that out of there, and only the 2 tokens with a 7 remain. So that is working just fine. Now going over to the client, we'll just rerun the client. We'll log in again. And on the client, we can immediately see attempting to log in, etc., etc., and right on the button, successful token verification. And we can go to the game server, and we can go to the remote explorer, and we can see that yes, indeed, we do have that peer connection, and we do see that that is indeed the user that connected. So that under the player verification, that create player container, that was done properly. We did have that token for a moment, even though we don't see it in this print. That's just because, well, the whole process was done within 10 seconds between those 2 timers hitting off. So everything works fine, and good luck copying this into your project. That was it for today, guys. Hope you like it. If you did, smash that like button, hit subscribe. Don't forget that little bell icon to make sure that you don't miss out on the next episodes in this tutorial series. In the next couple of episodes, we're probably going to be shifting a little bit to security. Very important for the fundamentals of a proper network architecture. We're going to be having a look at how we can encrypt our passwords we're sending over the network using SSL certificates, and we're going to have a look at how we can salt the passwords. Let's salt, from salt and pepper, to protect ourselves against rainbow tables. Now, what those are and how we're going to do that is going to come up in next episodes. I hope to see you there. Until then, keep on gaming, keep on coding. See you later, guys.